Today is May the 9th, 2023. It's about a little after 2 p.m. instead of 2 a.m. I usually make my videos in the early mornings, but normal daylight time now. I've shown this amplifier before on YouTube. I made a full video of it. It's my main amplifier. I use it in the living room on my main stereo. I drive clip horns with it. It does about a perfect 15, maybe 20 watts per channel, depending on how you want to rate them. These little UTC transformers right here are just jewels. These are LS57s, a pair of them. The power supply here in the middle is a transformer out of something from Sandia Labs, military surplus stuff. I used it in a voltage doubler. I remember it's like 700 milliamp. Secondary. These things are very thick and solid and heavy. They do a great job. I have run 6L6s or KT66s, EL34s, but I've got 7591s in it now. The 7591 is a different pinout from the KT66 6L6, so you have to redo it underneath. But anyway, this thing runs hours and hours a day. Sometimes I forget and leave it on all night. So this thing to run an average of 12 hours a day or more is not uncommon. But anyway, it's been running there for a couple of years, I guess. And it just quit on me. A couple of nights ago, I swapped it out with another amplifier, but I want to fix it. Got to fix it. And I'm going to show you what I'm going to do. I'll show you my approach. Not that my approach is any better than anybody else's, just my approach, and eventually I will win. I will fix it. I'm going to, I don't want to just start mindlessly swapping out parts. Well, anyway, I got it set up. I got the tube checker set up, but I have not started working on it yet. I haven't done anything to the amplifier. I've just got it set up ready to test on it. I don't blah blah too much. Look here. I bought one of these books off of eBay for my TV7. I like this. I like that a whole lot better than having to go through that little tiny book that's this little tiny book that's inside, the original. I mean, it's got everything. I don't know if it's got 7591 in it or not. Okay, let's see. We can see what's wrong with it. I remember when it quit working. Sorry, I got to move the camera a little bit here. And I went over to it. I could smell it. Something burned in it. I don't know what. We'll find out. Let's turn it over. And let's take the bottom off. Wish I don't know how to speed up my camera, but I may stop the camera and stop it a little bit so that it doesn't get too terribly long. I like bottoms on the amplifiers. I don't feel like that they're finished until they have bottoms on it. Sometimes I put little rubber feet on. In this case right here, I just put these felt feet on. I'll show you that a little better here. And get it on. See these little felt feet right here. These things work real good, not scratch your furniture up. Once upon a time when I built it, I put a schematic on the bottom. That's a good idea. I'm glad I did that actually, because see, now I need it. Okay, well, somewhere in here, man, it stinks. Something really burnt in there. I wonder what it was. Let's see. Let's get this thing up here. I'm gonna, the way that it burned, I'm gonna assume it's over in the power amplifier section. Well, there's something that looks suspicious. Look at that. Look at that right there. It looks like that got hot. I wonder if that's shorted. If that's shorted, it probably took a tube out. That's a good place to start. And it smells strong. Something went up in flames in this thing. I'm trying to get it so you can see in it really good, but it's kind of hard to do. I don't know if you actually want to see me try to troubleshoot every component in there, but let's see. Let me see. I got the meter out here. Got it turned on. Let's check those resistors. Okay, crosshair resistor. Let's see. One side's to ground. And it's 220 ohms. Oh no, it's not short. It's 218 ohms. See the meter right there? I don't want to zoom in and out too much. It's 218 ohms. So I don't see that capacitor shorted. Let's check the other one. 211 out of 220. That's not bad. Well, no, that doesn't look like. I wonder why that foil is back of it though. As you can see, that foil is kind of melted back. Maybe just the heat from that resistor. They look okay though. They don't look fried. But I sure can smell it. Well, it could be the power supply too. Oh my. Well, anyway. Oh, I'll tell you something that's always good to look at. Sorry. Something always good to look at is the fuse. Let's see the fuse. If it's catastrophically blown, it is. Look. If a fuse has kind of died a natural death, which I certainly don't think this is, or it wouldn't be stinking. I don't know if I could show you this or not. But look at that fuse. See that fuse? That fuse died a instantaneous death. It vaporized the, so something's shorted big time. Something took this thing out, and I'm going to guess it's either a tube or the power supply. Oh my. Okay, well I'm going to put the old one back in there right now, just so I don't lose the thing. I'll have to put a new fuse in it, of course. You know, I guess the first common sense thing to do is to check the tubes, the output tubes, because I don't think these 6SN7s can draw enough current to do that. These are let's see, these are from Tube Depot. These are 7591s. These are the Russian-made tungsol. I found them to be pretty good. Well, let's check them. Okay, this could take a few minutes, but I do have it all set up over here, so you didn't have to watch me fumble with that. Let's see. I was just looking them up in here. 7591. 7591. There it is, right there. 7591. 6.3. Here's how you set the switches. H is 6, 3450. Bias of 10. Range D. Press 3, and it should be a minimum of 36. So all this is set, so we should be looking for at least 36 on each one, and nothing shorted. Yeah, it's all lit up. Let's see, here comes the test. Let's see. First thing we got to do is do the line adjust. You always got to do the line adjust. There we go, set it right in the middle. 36. Oh, that's nice and strong. 36. That's 52. I don't see any weird shorts. You know, you can go through all the short stuff, but I don't. Because if the tube is shorted, it's not going to work. You're not going to get something like 52 out of 36. So that was good. 52. Wow. This thing's still good. These things have got a lot of hours on them too. Put that back in. We want to pay attention which ones we're pulling out too, because a lot of different one there. Let's see, check this one. Now we're going to check this one. We want to pay attention so we'll know if it's, you know, this half of the amplifier that burned or this half that burned, because we don't know yet. Okay, we'll let it warm up. It's going to take a minute. See, that other measured 52. Okay, there's our set, our line adjust. Doing that just to waste time. 52. What does this one measure? Wow, I'm impressed. 50. Yeah, and it's steady. I have found out when you hold this thing on like that, some people say you're not supposed to hold it on very long, but I don't hold it on terribly long. But if it's dropping, if I see it dropping, it seems to me to be an indication that the tube is weak and the cathode emission is failing. Well, I'm impressed with that. Those two are still really very strong and very close, 52 and 50, very well matched. I remember when I got them and put them and measured them before I put them in there, they were very strong and matched. That's good. Oh wow, I'm impressed. I'm not trying to sell you these tubes. Okay, well, anyway, let's keep going. I don't think those tubes are bad. Okay, now let's do this one. Boy, these things are tight. I use military surplus sockets and stuff. That's when they made them. That's when they made good sockets back there, like in the 60s, and maybe, I don't know, they probably started cheapening down in the 70s when we went to solid state. But these old military sockets are good. They're made out of nice, hard, stiff spring steel, and they don't get, when they get hot, they don't get soft. They hold those tubes in there like they mean it. Okay, let's see what this one measures. 50 and 52. I'm impressed. All right. Line adjust. Oh, that's still good. Okay. 46. Out of 36, so it's still, you know, well above minimum, and it's nice and steady. Okay, 46. Okay. So we don't take up the whole abdomen here. 46. Looking kind of fast here. I don't want to get too fast and break something. 46. And let's see what this one measures. I'll put that one in. See, this is one we just measured. Now we're measuring the next one. So maybe we'll find a bad tube here in a second. I don't know. Not sure I have any more new ones. Line adjust is still good, and it measures, what did it make, 46? This one measures. Uh-oh, well, we gotta let that one warm up a little bit longer, haven't we? Well, that's the fun thing about, you know, watching tubes warm up. I guess it's kind of like watching grass grow, huh? Warms up a little bit faster than grass grows, but okay. Well, that one's, well, from my angle, that's about 45. Oh, wow. I didn't really expect that. Okay. Well, you don't want to fight success. You don't want to go out and just, you don't want to shotgun it out if you don't have to. By replacing all the tubes. Excuse me if I step out of line here, but some people think that every time you take the bottom off of an amplifier, you got to replace all the capacitors in it. That is nonsense. Okay. Well, that looks pretty good. I don't think we'll go through all those 6SN7s. They are so far down. Here, let me show you here. They are so far down the line as far as the power supply. See, the power supply is right here. I didn't draw it out. Just this is a LT Spice program that actually works. You can simulate this thing. But the see, the power supply goes straight up to the transformer and to the plates and all that kind of stuff. So you can get some high current in here, but they go through some resistors, a 1.8K resistor, 22K. You're not going to get enough current through these things for this part of the amplifier to burn and smoke. It's just not possible. Okay. So, but it was a catastrophic failure because it vaporized that fuse big time, and it smells really bad. Let's look back down in there. Did we find anything? I built it in October 2020. Left channel, right channel. It's good to take time and label your stuff. I did the best I could at making them very symmetrical. This channel and that channel, how they look alike mechanically. I like that. I'm just talking while I'm thinking what I'm going to do next. I've got the little RC circuits in here to snub out parasitics. These pots right here and here, left and right channel, are for balancing the output that drives the output tubes. This one balances the output stage here, the 6SS underdrive. These two tubes, these little pots right here, and with this one right here balances the cathode current on these two tubes. So this one is the same thing on these two tubes. So you want everything as balanced as you can possibly get it. So you balance the drive voltage into the tubes with this one. You balance the cathode currents through the tubes with this one. And these right here are filament hum balance pots. I guess I gotta start checking those diodes or something. But I ought to be able to see something burnt in this thing really bad. This smells terrible. But I think it's something up here in the... Well, I'm wasting a lot of your time, huh? Trying to get the light over here. Stay. Let's just look it over. I don't see anything. I do see something. Look. I do see it. Look. That resistor. That's weird. Let me see if I can zoom in on that. Can you see that? The resistor's cracked. Look at there, that thing busted plumb in two. Can you see that? Look. Well, what in the world would cause that? 1800 ohms, 2 watt. Well, yeah, it does smell like a burned resistor. I guess you could see that. Well, there we go. We found it. I wonder what caused that. Well, let's see. I kind of remember that. Yeah, I saw that in the schematic, an 18K, 1.8K. I see it there. It goes from, yeah, this is the power supply voltage right here. This is the, darn. The high voltage is right here, right straight from the power supply, and it goes off of there. Goes up to this wire. If we follow, just follow that wire out. What's this wire? Goes over right here. Huh. Maybe that's it. Maybe there's that. Maybe that capacitor to ground is bad. I guess that could happen. That would be this guy right here, maybe. Yeah, this is what's burnt open. So you have to look at this and say, what could happen? What could cause that thing to burn open catastrophically? Well, it can't be this, because that'd have to be burnt open too, and you can't get enough current through this to burn it open. Not 22K. Goes up to here, it goes through these, well, that's that balancing resistor, 47K, so you can't get enough current through there to balance it. You could get enough current through here if this thing's shorted. It's coming out of the power supply, yeah. Yeah, we're tapping this off right up here at this tap. No, it's not that one. That's on the wrong side. That could be shorted. Where is it now? Which one is it? What's that one right there? Okay, well, let's see if it is. Let's use a good old analog meter. Put it on times 10. Times 10. Hope you can see what I'm doing. Kind of maybe. I'm going to measure across this resistor right here. Well, let's see. First of all, let's see if our meter is working. So put our meters to meter these together and look at our meter up there. You see our meter. So, okay, so that's basically 0. get all excited, and then it has nothing to do with it. It happens all the time. And let's see, let's put that across that capacitor. Wow, it is, it actually is. It is it. It's shorted. Look. Look. The capacitor's shorted. Oh, that makes sense now. Yeah, that actually does make sense. If that thing just out of the blue shorted, that would short the, of course it may have taken some, it took the fuse, that's for sure. It may have taken some power supply components. That could have happened when it, well, okay, well, looks like I got my job kind of cut out for me. I got to replace this, this 1.K resistor right here. I'm going to take this thing out and check it with it out of the circuit, make sure that that's it. Well, let's try to pull it out, replace the fuse, and maybe just turn it on, see what happens. Sometimes you just need to turn it on and see what happens. Let me show you one other thing I got here. I've been wanting to show this ever since. To turn my, so that I don't forget, I actually got this from my friend out in Australia, this idea, but recently I replaced it with this great big timer for photographing, for photography stuff. This way I turn my soldering irons on. Oh shoot. And I put it there for 59 minutes. And that way if I walk off and, you know, flew the coop around here, my soldering irons don't stay on for a week at a time. So I just turned them on. That'll have to warm up. Okay, well anyway, I got a little work to do. I'll be right back. Back in just a second. Okay, we're back. And here's the bad one. Measure it right here. So you can see the meter. You can see the meter deflect when I hook it up. So it's just dead short. Okay, trash can. And this poor little resistor that was sacrificed, it just burned it completely in two. Okay, trash can. What I also did, and we're going to find out, seems like I kind of remember, it's interesting that I even put a little sign in there somewhere. It said, oh yeah, right there. What does it say? It says danger. Sorry, I'm going to drop this thing on the floor if I'm not careful. 460 volts. My God, everything is in the way. Okay, 460 volts. Okay, that's okay. Because this is a voltage doubler, and these two are in series, so that's the 460 volts is across that. And these are two 450s in series, so that's 900 volts. So we're safe there. They're not gonna be over voltage, but I think I kind of remember that. Okay, I'll show you right here. Like say we got 460 right here. When we first turn this thing on, and all these tubes are cold, and there's no load out here, this resistor there's no drop across it because there's no current flowing through it. So this thing right here is going to end up at the same voltage as these are, which is the two in series. These are the two 220s in series. I'm drawing it simpler than every little detail of it. So I've probably been over voltaging this thing on power up for quite some time. Let's see, it is cold now. I have not turned it on. So let's measure the voltage there and see. We're going to hook that up. Hook it all up. Hope I don't short things around. Don't have it turned on. We're going to see what that voltage soars up to. Let's see, I got the voltage on. Let's see. Okay. Let's see what that voltage actually goes to. I'll power up. Okay, are we ready for this? Stand back. Is everything ready? I'm always nervous when I first turn on. Okay, here goes. Yeah, look at there. Okay, that's probably been over voltaging that capacitor for some time. It's 490. I bet it comes down to below 450 once it warms up. There we go. So that's probably what shortened the life of it. Yeah, you know, there's a it's 430. Well, that's pretty close to that darn 450, isn't it? So it was running really close. That's a known common problem with some of the Dynaco amplifiers. Especially if you put solid state rectifiers in there, it's going to over voltage the capacitors pretty quick. Yeah, that 430 volts is too close to 450. Okay, let me turn it back off. Unplug it. I want that thing to go down so it doesn't kill us. Okay. Well, what I did on both sides, that thing I disconnected. What I did on both sides was I put 500 volt caps on it. I actually didn't have any more of these same ones, so I put these in there. I don't know if you can read that. They're 47 at 500, and so I changed them both. This one was not bad. That's this guy right here. When it came out that side, it's not bad, but it's been being over voltage. I'm just going to throw it away. Here's another thing that I noticed. Is see that resistor right there? That's the one I just replaced. You can see the colors in it are actually quite good. Brown, gray, red. That's 1800 ohms. The silver band, 10%. Here's the one on this side. The brown, gray, red are pretty good, but that silver one is burnt kind of brown. So I bet this resistor right here is running pretty much at its maximum power level. I mean, we can measure the voltage across it and do E square over R. It might be better if I wanted to make it last forever. Just someday maybe put 5 watt resistors in there. That'd probably be a good idea. Yeah, can you see how that, see the brown, gray, red, and then it's brown again? That's not a 1% resistor. Probably used to be silver. Probably been pretty hot. Well, anyway, it powered up. It is unplugged. Let me set this back down. I know I'm moving around a lot, but I just don't have the time to. I got to do these things by the seat of my pants. Well, I think it'll work now. I tell you what, I'm confident enough to put the bottom on. And let's make some, well, no, I don't want to put the bottom on because I want to make some measurements. I want to show you, I've done this before, but I want to show you how important it is to distortion to be able to adjust to be able to make the drive voltage into the two tubes equal and make the current between the two tubes equal. That's what these do. This one adjusts the drive voltage to the two, and this one adjusts the cathode current to the two so that they're balanced. Left channel, same thing over here on the right channel, and that changes things considerably in the world of harmonic distortion. Yeah, all the rest of the capacitors are fine. These down here are 500 volt. The ones off the same point on the other side. So we're okay now. Yeah, those poor little capacitors. Actually, they did pretty good. I guess for cheap ones, this one hasn't gone bad yet. But on terminal, it was going up. I think close to like 490. So it was being over voltaged for a while. Be right back. 1 second. Okay, well, I got all the equipment on here. I'm going to let it warm up for a good half hour here. All this stuff right here that any of you that watch my videos have seen this many, many times. But I thought in the process, so just letting it warm up, I'd do something right quick and figure out how, I said that it looks like that resistor right in there has gotten pretty hot. And the voltage across it, if you can look up there, is 43 volts. Right there on the digital meter. As you can see that. 43.2. So power dissipated in that resistor is the voltage across it divided by the resistance. which is E squared over R. And if we do 40, let's call it 43, and then we square that and divide it by 1800, we get 1 watt, 1.03 watts. I hope you can see that. So we're really not we're really not dissipating too much power in that resistor. Let's turn it all off and disconnect it. So I'm not going to worry about it. We're dissipating 1 watt and a 2 watt resistor. So it's going to get a little bit hot. But we haven't, you know, we're not abusing that resistor, let's say. Okay, let's let it warm up a few minutes. Be back in just a couple seconds. Okay. Well, let's do some basic measurements. We got 500 volt cap right there. And our actual plate voltage is not the 460 I wrote in there. Okay, so that one's okay. And we know it doesn't soar above 500 for this one. It doesn't soar above 500 for that one either. 490, it goes right up to it, but it doesn't go over. So that should last a long time. We know that we're not dissipating but 1 watt in these little resistors. These up here, these capacitors, these are all 450. Let's see what they're rated. They've got only got 194 volts across it, so that'll last forever. And the other one has got 285. That should last forever. Sorry, none over, and you know the two sides, they're the same. So we don't have any, I don't see we have any capacitor voltage problems. I don't see that we have any resistor power problems. So I think it's going to last. Yeah, those two were getting abused for quite a while. Well, okay. I'm driving it right now just for a few watts, actually 12.88 watts at a kilohertz. THD 0.7%. Looks real good. It's just barely starting to do something to the top side. That's why we measure that 0.7. If we run it down just a little bit below that, it completely goes away. If we run it down to like say 10 watts, 10 point something, whatever. That's our sine wave. And our THD is around 0.3%. I have been checking this one out right now, and it does it on both channels. Both channels are virtually identical as identical can be. Now, if you ever just want to know this, let's get that horrible glare off. If you square this number and divide it by 8, you get this number. Because we got 8 ohm resistors. Here's the dummy loads up here. These are 1% resistors with a extremely good what's called a temperature coefficient, meaning that they don't change their resistance. And I've had these resistors so hot, oh, I mean, just screaming hot in this thing, 8 ohms. They're actually worth the money. But I won't go into a whole lot of let's measure this and tweak that and all that kind of stuff, because that can go on for eons. What I did do that I don't think is worth going over again, because I've shown this in previous videos, is I watch the THD up there, and I adjust the balance here, as I mentioned a while ago, driving the tubes, and then I adjust the balance here of the current through the tubes for minimum distortion, and then I go over here and do the same thing. We happen to be on the the right channel right now, and when I move this over to the other channel, then I just go up here and switch this one to the other resistor, and then we look at it down here and see, well, we had 10 watts a while ago. Now we got 10.4, THD 1.9. Seems like it's slightly lower on that one, but it looks like it's back in tip-top shape. So anyway, I haven't made a video in quite a long time. I don't know how much longer I'll even make videos. But you guys have, I've learned as much from you guys making these videos as you've learned from me. So I always appreciate the comments and discussions. So stay safe, my friends. And thank you for watching.